There's a default computer hiding inside your laptop, and most people have no idea it's there. Look closely at Apple's M-series chip, and you'll find a CPU, a GPU, a neural engine, and now neural accelerators all etched onto a single sliver of silicon. This one tiny die can run advanced artificial intelligence entirely on its own. Power that once filled an entire room now fits in your hand. No data center, no cloud. Just the machine already sitting on your desk.
Rewind to 2020. Running a model like this meant a server rack that cost $30,000, burned 700 watts, and needed its own dedicated room. Now fast forward to 2026. The very same job fits inside a Mac that costs about $4,000 and sips power quietly on your desk. The whole room just collapsed into a laptop.
So how does a single chip pull this off? It isn't one brain, but three, all working together. First, the neural engine, a processor built purely for artificial intelligence. Second, the GPU, which now carries a neural accelerator inside every single core. And third, the CPU, coordinating the entire flow. Because they share one unified piece of silicon, data moves between them almost instantly, with no copying and no waiting. Three specialized brains, acting as one seamless system.
And the pace of progress here is staggering. Back in 2017, Apple's neural engine managed about 0.6 trillion operations per second. The M1 hit 11, the M2 nearly 16, the M3 18. Then the M4 leaped to 38. That's roughly 63 times faster in just 7 years. The M5's figure is under wraps, but the curve points straight up. It's one of the steepest climbs in modern computing.
Here's the biggest shift in the M5. Picture a hospital with a single laboratory. Every test has to wait in one long line. That was AI on older chips, one central unit handling everything. The M5 places a mini lab inside every GPU core. Now hundreds of tests run at once, in parallel. Each core gained its own neural accelerator, delivering up to 4 times the graphics AI performance of the M4, and 6 times that of the M1. Everything happens at the same time. That's the power of true parallelism, built right into the silicon.
So where does all of that data actually live? This is Apple's real secret weapon, unified memory. On a typical PC, the processor and the graphics card each keep separate memory, joined only by a narrow pipe. Data crawls back and forth through that bottleneck. Apple instead pours everything into one shared pool. The CPU, the GPU, and the neural engine all drink from the same wide reservoir, at over 600 gigabytes every second. Nothing gets copied, and nothing waits in line. It's one enormous highway, instead of a thin little straw.
And this matters enormously for large models. Take a high-end gaming card, the RTX 4090. It has 24 gigabytes of memory, but a 70 billion parameter model needs around 40 gigabytes just to load. It simply doesn't fit. A Mac with 128 gigabytes of unified memory swallows that model whole and runs it at roughly 18 tokens per second. Bandwidth climbs too, from 153 to 307 to 614 gigabytes per second. Capacity and bandwidth are everything.
But how do these models run so efficiently? 2 clever tricks. First, a mixture of experts. Imagine 20 specialists sitting in a room. When a question arrives, a gate wakes only the 1 to 4 experts who actually know the answer, while all the rest stay asleep. 20 billion parameters exist, but only a few billion ever fire at once. Second, quantization. Think of shrinking a heavy hardcover into a paperback and then into a tiny pocketbook, cutting the model from 280 gigabytes down to just 40. Smaller, faster, and still remarkably smart.
So what does all of this actually cost you? Let's run that same 70 billion model 2 different ways. A Mac Studio with an M4 Max and 128 gigabytes runs it silently on your desk for $3,999.
The equivalent data center GPU, an NVIDIA All-100 runs $25,000 to $40,000. And that's before you add the rack, the power, and the cooling. That works out to roughly 1/6 the price.
Then there's the power bill to consider. That Mac draws around 80 watts, about what a single bright light bulb uses. The H100 pulls 700 watts, 7 to 10 times more, and it almost never runs alone. Now zoom out, and the problem becomes enormous. Data centers consumed about 415 terawatt hours in 2024, and that number could nearly double to 1,000 by 2030. Sometimes the smartest move of all is to simply use the computer already sitting in your bag.
There's another quiet advantage here, and that's privacy. When you ask for something simple, your Apple device handles it right there on the chip. Your data never leaves. When a request is genuinely complex, it travels to private cloud compute, encrypted end-to-end, and verified by independent layers of trusted hardware. Either way, your personal information stays protected. It is either never sent at all, or never readable by anyone but you.
And this silicon powers things you can actually touch. A Siri that understands what's on your screen. Image playground, creating pictures in seconds. Writing tools that rewrite a message instantly. Notifications that summarize themselves. All of it driven by a 3 billion parameter model running right on the device, and responding in under a millisecond. It feels almost instant. This isn't AI buried in some faraway server. This is AI you can see and feel in your hand.
Developers are clearly noticing this too. Apple's software stack is quietly converging. There's Core AI, the successor to Core ML. There's MLX, built specifically for Apple Silicon. And Ollama, a hugely popular tool for running local models, is now switching to MLX for a 20 to 50% throughput boost. Piece by piece, the entire ecosystem is standardizing on Apple's own stack. And when the tools line up, real momentum follows.
So how do you map all this to the market? At the center sits Apple, ticker AAPL. Around it orbits a constellation of players. TSMC, which fabricates the M5. ARM, whose architecture underpins the design. ASML, whose machines print the chips. NVIDIA, the AI incumbent. Plus Micron, Qualcomm, AMD, Intel, Google, and Broadcom. Each one holds a different piece of the same puzzle, all riding one silicon wave. And remember, this is education, not financial advice.
Of course, there are always two sides to every story. The bulls point to 2.5 billion active devices, deep vertical integration, and a genuine privacy moat. The bears counter with a lagging Siri, NVIDIA's powerful CUDA software lock-in, and a premium valuation near 35 times earnings. Analyst price targets currently cluster somewhere between $310 and $400. Smart investors always weigh both sides carefully before deciding.
So, zoom all the way out, and the picture is remarkable. 2.5 billion Apple devices, together forming the largest distributed AI platform on the planet. A brain inside every core, privacy by design, and one unified stack the whole industry is now building on. Next time, we'll explore AC/DC, Apple's path from your pocket to the cloud. If this helped it click, hit like, subscribe, and tell us which stock you're watching.